Hello, my name is Davis. I'm an educator here at the Museum of Life and Science. Today we're going to be doing a bite-sized activity with materials you can find in your home. We're going to be doing today a Cartesian Diver. Cartesian Diver is going to help us learn about buoyancy and density. For today's materials, you're going to need a bottle of water, some paper clips, a rubber band, a drinking straw, a glass of water, and a pair of scissors. So today we're going to be learning about buoyancy and density. Buoyancy is the tendency for an object to float in a fluid. That fluid could be a liquid or a gas, like the air around us. Density describes how compact matter is in an object. Generally, the more compact the matter in an object is, the more dense it is, the more likely it is to sink in a fluid that is less dense than that object. If an object is less dense than the fluid it's in, it will tend to float. Now we're going to demonstrate these concepts by making our Cartesian Diver. To make a Cartesian Diver, you're going to take a straw. I've cut my straw down to about 6 inches. That's about all the length you need for this activity. So what I'm going to do is fold my straw in half. It doesn't have to be perfect, but we're going to get it close. I'm going to pinch the end so that that end is very crimped. Next, I'm going to take a rubber band and I'm going to wrap the rubber band around the ends of the straw so that it holds the two ends together. When you're finished, it should look like this. Next, what we're going to do is take the straws, place them into our glass of water, and we're going to squeeze some of the air out of the straws. You should be able to see bubbles come out of the bottom. That air that we're squeezing out is going to be displaced by water. That's going to increase the density of our diver. Once I have that done, I'm going to take a paper clip and I'm going to hook the paper clip into the rubber band. I'm going to go ahead and put on about 2 or 3 of these now, and we're going to see if our straw is more dense or less dense than the water. We're going to do 3 just to be safe. When I place it in the water, the paper clip should weigh down one end and it sinks. That's good news. That's a good result for us. So what we want to do now is we want to decrease the density by removing a paper clip. Now let's try again. Great, it floats. We're going to continue this process, and you might find that you need more paper clips or fewer paper clips, but you continue this process until your diver is floating just above the surface of the water. Once we're certain that our diver is less buoyant than the water and will float, we can remove it from our glass of water and we can place it into the bottle of water. We're going to take our diver, place it in like so, and see that it floats. One final step, you do want to top off the bottle with the water from your glass so that there's no air remaining in the top. Once we've got that, we can put our lid on and our Cartesian Diver will be complete. Now, our diver is sitting at the top of our bottle, and what I'm going to do is I'm going to pick it up and squeeze it. When I squeeze the bottle, what do you think will happen? Will the diver fall? Will it stay in the same place? Will it move side to side? Let's find out. As I squeeze the bottle, the diver begins to drop. With the right amount of pressure, I can make it stay in place. With continued pressure, I can make it fall more, and as I release the pressure, the diver will rise. As I squeeze the bottle, the water is compressed. That compression causes the air inside the diver to compress as well, which makes it more dense. If the air becomes more dense, it becomes more dense overall than the water, and the diver begins to fall. As I release that pressure, the air expands. As it expands, it becomes less dense and the diver begins to float again. Now that your Cartesian Diver is complete, there's lots of ways you can continue to experiment with it. You can take the paper clips and make them into hooks to try and pick things up off the bottom. You can also try using a different size bottle. Maybe an oval sized bottle might affect the diver differently. Finally, it's interesting to think about how weather might affect how well your diver works. I hope you've enjoyed making this Cartesian Diver. We'll see you next time.